Today we'll solve the problem of the day. The problem is the lowest common ancestor. Lowest common ancestor in a BST binary search tree. Given a binary search tree with all values unique and two nodes value n1 and n2. Both the value n1 and n2 does not equal to each other and find the lowest common ancestor of two nodes in BST. We are given a binary search tree. In the binary search tree we are given two nodes and we have to find the lowest common ancestor means first ancestor which is the common in both of the nodes. Both of the means in the two nodes which first ancestor which is the common in both of the nodes and we have to return that node. This is our task. Let's understand by the example. If let's suppose n1 is, first node is 7 and n2 is the 8. So what will be the ancestor of the 7, 6 and 5? What will be the ancestor of 8, 7, 6 and 5? Which one which first one which is in common in both of them? 7 is common in both of n1 and n2. 7 is the first ancestor which is the common in both of node. Let's understand by the example. In the example, we will see first node is the 7, second node is the 8. First, this is the binary search tree. First, search the element. Element is the present or present in the binary search tree or not. How to this is the binary search tree? Then we can search an element in the login time in the BST. First, our first job is to search the element in the binary search tree, and next is the store all the ancestor, and third point is find the lowest ancestor. Which one ancestor is the common in the both of them. In this example, we will say this n1 is 7. All the ancestor of n1 will be this 5, 6 and 7 are the node n2 equal to 8. All the ancestor will be 5, 6, 7 and 8. This 7 is the common. This 7 is the common first common node which is common in both of them. Let's understand by another example. Let's suppose the n1 is 9 and n2 is 12. What will the first common ancestor? This node 10. Node 10 is the first common ancestor in this example. Let's understand by this another example. N1 is the 1 and N2 is the 4. What will be the ancestor of N1? N1 ancestor will be 2. N1 ancestor will N1. This is N1. N1 ancestor is 2. What will be ancestor of 4? Fourth ancestor will be first ancestor will be 5. Second ancestor will be 2. Which one is the common? 2 is the common in both of them. That's why 2 is the common ancestor in both of them. What will it, how to do this? First, search the element where the element is present, and next, return the lowest common ancestor. Let's understand by the code. I will explain each and everything in the code. Our first job is search the element. If element is present in the node, then we will return a list of all ancestor. Okay. If the element is not present, we will return the false. I will say element is not present in the binary search tree. Search element will take the three input as a parameter. First will be node, second will be int n, and node which we have to search, and third And third parameter, there will be no third parameter. Okay. This will return a boolean value. It will return element is present or not. Third parameter will be vector, where we will store all the ancestor. Third parameter will vector. In this vector, we will store all the ancestor. Check if the root exists. Okay. If root data equal to n means first we will push the node in the list of ancestor. If the that node is not coming in the list of ancestor, we will pop that element. First we will push the element. First we will push that element in the list of ancestor and check if the root data equal to n, then return false. Return true. Sorry. If the element is present, then return it true. If the element is not present, check if n is less than root data. If n is less than root data, then search in left side. If n is less than root data, search in left side. If search search in left side, go to the left and we, if the element is present in left side, return true. Else if n is less than root data, then search in left side. If n is greater than root data, search in right side. If the element is present in the right side, return true. Otherwise, if we have searched all the elements, we didn't found the element and that not if n is not present in the binary search tree, then we will easily return false. False. We will say element is not present in the BST. Okay. We will have two vector of node v1 or the n1, v2 or the n2. All the function search for the n1 and pass the v1 and search for the n2, pass v2. We have stored the ancestor of n1 in the array in the vector v1 and the ancestor all the ancestor of n2 in the vector n2, vector v2. N1 will be the size of v1 dot size, n2 will be v2 dot size, n2 will be v2 dot size. Int n equal to minimum of n1 comma n2. Why we are doing this? We will take the minimum size of both of the vector and traverse from 0 to the minimum size. And while our int I equal to 0, while our I is less than n, minimum of both sides, and given I data equal to v2 I data. While v1 I data is equal to v2 I data, continue, we will continue I plus plus. If this condition becomes unsatisfied, then we will return given of I minus 1. At any point of time, if v1 data is not equal to v2 data, then its previous nodes will have been common. This is let me submit this code. This will work or not. No, we have to push root, not root data. Okay. If root data is not equal to n, if n is less than root data, in the case of in any branch, if that branch is not containing the ancestor, what we'll do? We will pop the element if we are going in any direction. If that direction is not for the that direction is not, if we didn't found the node in that direction, we will simply will pop the all those elements in that direction and search in next direction. Okay, let me submit the another. Yes. Okay, it's working. Change the test. Yes, it will work or not. Okay, it's working perfectly. Let me submit the code. This will work or not. Okay, our code is working perfectly. Let's summarize the code. First, what we have done, did first search the element in the node. What we did, if the root is not null, push the root push the root data into the list of the ancestor. If the root data equal to n, then return true. We have found the node n. In the case of n is less than root data, search in left. If element is found in left, return the true. If the n is greater than root data, search in right. Okay. If we found in right, we will return true. We will not go here. V dot far back. If we found the root data in right or in the left, we return. We will go back from here. If the root data is not found in left, right, then what pop tho- that root, that node from the list of ancestor and search in the another direction. In the case of element is not found in the BST, we will return the false.